Good morning, everyone. Welcome back to our college algebra course. For this week's lecture, I'm going to cover section 3.1. We'll be talking about function. And I claimed we actually seen function before quite a lot, but we may not call them functions yet. So let me give you an example of what we may seen before. Say, example, y equal to 2x minus 1. You guys probably recognize it right away. It's called a linear equation, right? Graph of this is going to be a line, y equal to x minus 1 slope intercept equation, where 2 is the slope and negative 1 is going to be the y-intercept. Okay? Or maybe something like this. Y equal to x squared minus 3x plus 4. And we call it what? Quadratic equation. Okay? And I claim they actually all functions. So what does it mean by function? You guys have something called input and output. And our tradition to denote x for the input and then y for output. Okay? Of course, we may use different letters, but it's just our habit for now. And then what? Whenever you assign a value for x, means what? Whenever you give the input and value, you plug into the equation, you're going to get back the y value, which is an output. Okay? Say, for example, the first one right here. When I plug and say x equal to 5, I got what? 2 times 5 minus 1. I got 2 times 5 is 10 minus 1 is 9. I got back y equal to 9. Okay? So plug in the input, get back the output. That is the idea of function. Okay? And more specific than an equation, the function is going to satisfy one condition. For each input x, you can only allow exactly one output y. Okay? So something that's not a function. So let me give you a counter example. Say y squared equal to x. And now, what? Again, x is the input and y is the output. Okay? When I plug in, say x equal to 9. X equal to 9. What do I get for y? I can have y equal to 3. Because 3 squared is equal to 9. Okay? But be careful, because in here, 3 may not be the only output. I can have y equal to negative 3. You guys see why? Because negative 3 squared is equal to 9. So for x equal to 9, you plug in, you got two different outputs, and this is not a function. Okay? This is not a function. No. Okay, so that's the idea, this basic idea of function. It's like a relationship between x and y, between inputs and outputs. For each input you plug in, you can only get back exactly one output. And if you have an expression like that, we call it a function. So first, let me write a formal definition of function. Number 1, definition. A function is a relation between input x and output y, satisfying or such that for each input x, there exists exactly or a unique output y. Exactly one output y. Should be for each. I'll put a word valid in here. Okay? Valid input x. It means that sometimes you cannot plug in a value for the input x, and I'll talk about that when we get to the domain and the range. Okay. Anyway, it's like a mapping. Many people call it mapping later on, a relation between two variables or two elements in general. Whenever you assign some value for x, then you get back something. Okay? That's called the function. That's a concept. That's the idea. And we'll talk about notation. We denote the function this way, f of x. Called f of x, f is the function, I guess. So this is the function in terms of x. And then later on, we can change the letter. We have g of x, k of x, h of x, whatever. So say f of x, the function. So f of x equal to 2x minus 1. This is a function, okay, where x represents the input, and f is a function. So f of x is the same thing as your y that we see before. Same thing as right in this, 2x minus 1, okay? So now this is our official notation to represent a function, all right? So with this example, say if I write f3, I'm using this function right here. What do I mean by f3? It means what? I'm plugging 3 for input. This is my input. Okay? And what do I mean by plugging 3 for the input? This is my function, or you think of it like a recipe. Okay? So what do I do with this? The recipe say what? Whenever I got an input x, I'm going to double the x and then minus 1. So 2 times 3 because x now is 3, and then minus 1. I got 5 come out. Okay? So I plug in 0. So f of 0 equals to 2 times 0 minus 1 is equal to negative 1. Okay? So if I plug in h, what do I have? 2 times h minus 1. And I don't know what h is. Could be any number. Okay? If I plug in, say, star in general, then what? 2 times star, and then minus 1. If I plug in, say, x squared, now what? It's like a machine, okay? The function is a thing. It's just whenever you plug in, follow the form of the recipe. So what? 2 times the input, so 2 times x squared, and then minus 1. Okay? What if I plug in, say, x plus 3? Function say what? No, I'm gonna, now I understand the input is x plus 3. So I'm gonna double it, 2 times x plus 3, and then minus 1. Of course, go ahead and simplify it later on. That's the idea. So if I plug in f of x plus h, oh, well, I don't know what h is, just a letter somewhere. So what? Follow the formula. It's going to be 2 times of x plus h, and then minus 1. Okay? So hopefully, via examples, you guys understand the idea of functions. See what in here? Whenever you have, you are given the notation of f of x equal to, say, in this example, a combination of x. In this example, 2x minus 1. It means what? Whenever I receive an input x, my formula is what? My job is what? I'm going to times x by 2, and I subtract 1. I'll give you back an output. So I'll give you an example right here. Not an example, a lot of examples. When I put in x equal to 3, double the 3, minus 1. Okay? I receive 0, I double the 0, minus 1. I receive an h, I double the h, and then minus 1. I receive a star, I double the star, and minus 1. I receive x squared, I double x squared, minus 1. I got what? X plus 3 as input, and I just double x plus 3 and then minus 1. Of course, I see in here we can simplify, but I'll just try to emphasize the idea of function. Okay, that was the definition of function. Now let me talk about the next item, function. I'm going to talk about the domain and range of the function. Number 2, domain and range. Okay, so let's start with domain. I'm going to start with the next one. Whenever you hear the word domain, you guys are going to think of the x value for me, the input. Okay, domain is set of all inputs x. Okay. In our course, college algebra, we are talking about real numbers. So usually we think of real numbers or just part of the real numbers. Let me give you an example. F of x equal to, we'll do the same thing before, 2x minus 1. Now you ask yourself, what value can I plug in for x? technically anything, right? You can plug in positive number, negative number, any real number. So the domain is all real numbers. Okay? And this another way is we learn to represent all real numbers. We can use the interval notation, say parenthesis negative infinity to positive infinity, or some later on we just denoted by a capital R. It means all real numbers. Okay, many ways. Right? Now let me give you another example to show you that the domain may not be all real numbers. Okay? Now I'm tired of using the notation f of x. I can change the letters. Say g of x is another function. If I give you this, 2 over x minus 1. Now you see what? X is the input, right? This is also a function. But this x is on the denominator. So we have a fraction. So a fraction has some restriction. The denominator of fraction cannot be equal to 0. So you can plug in any real numbers for x except for one value. You cannot plug in x equal to 1. You see why 1 is not okay in here? Because when you got x equal to 1, then what? 1 minus 1 equal to 0. The fraction becomes 2 over 0 is undefined. So you see that if I plug in 1, see what I got? I'm going to erase it later with that. G of 1 is going to be 2 over 1 minus 1 equal to 2 over 0. 2 over 0 is undefined. Okay? So you can technically plug in any real numbers except for 1. So the domain is what? Oh, D stands for domain, okay? All real numbers except x equal to 1. Okay? Or you can use a set notation. You can write this way. All real number x, okay? X cannot be equal to 1. Curly bracket. Or you can use the interval notation. You can write this way. Anything from negative infinity up to 1, but not including 1, and then union from 1 to infinity. Okay? Many ways to write the domain. You don't have to write it all when you get to your exercise. It's just one of those ways. And I think you can see them all in the homework. Okay? Either one of those three. Okay? How about another one? Another example. Oh, f, g, how about h of x? Say equal to square root of how about x plus 2? What were we seeing in here? A radical notation, all right? Square root. And in terms of real numbers, we're talking about real numbers in college algebra. So in terms of real number, whenever you have a square root, the quantity under the radical notation or under the square root cannot be negative. You can take square root of 0, square root of 1, square root of 3, but you cannot take square root of, say, negative 1 yet. Now, we will be talking about this when you talk about complex number. But for now, in terms of real numbers, the quantity under the square root is going to be positive. So what is the condition for having a valid input x? Condition is x plus 2 going to be greater than or equal to 0 because you cannot take negative. So x is greater than or equal to negative 2. Okay? It means that what? Whenever you want to plug in a valid, good input x, you have to plug in something that is greater than or equal to negative 2 for x. Okay? So the domain for that function h of x is what? All x by all real numbers greater than or equal to negative 2. But that's too long, so let me write it this way. X greater than or equal to negative 2, right? So use interval. Negative 2 all the way to infinity. Yeah. Or you use a set notation, all real number x, it's supposed to be this way. Yes, the book didn't write it yet. But this is what it means is x is a real number, and x is greater than or equal to negative 2. Okay? I think our book just write that much. But it's clearer to say that x is a real number. That is about a domain. So whenever you hear the word domain, you are thinking of the input x for me. Okay? And we have to look for the condition that make the input valid. Alright? So the first example right here, you plug in anything, you're free. Right? You have any real numbers you can plug in. Okay. Second example right here. You see, depending on the nature of the function. This one is a fraction where x is a denominator, and you are not allowed to get denominator equal to 0. So you got to rule out those cases. And in here, the restriction is x cannot be equal to 1. So the domain is all real numbers except for 1. And then I show you the third example, which is a radical function. We have square root of x plus 2. We know that in terms of real numbers, the quantity inside the radical, in this case it's x plus 2, cannot be negative. It's got to be greater than or equal to 0. Now you find a condition for x, and then it's help you to find a domain. So you see what different example different function gonna have different conditions for x. So 3 example will not represent all type of functions, obviously, but I show you the idea of how to find a domain of the function. Okay. Whenever you have a function, the very first thing that you're gonna care about is the domain of that function. Okay, it's very important. Next, I'm gonna talk about the range of function. Number 2, the range. The range is the set of all outputs y. Okay, so x you have domain. The range you have the y. Or y is the range. Okay, so whenever you plug in an x, you have the y come out. And y value come out is the element of the range. Okay, part of the range. All the value y together is called a range of the function. And honestly, I don't know how to talk to you about the range algebraically, but I can find another way to show you how to look for the range of domain of function. Like not really a formal way to get it right, but for now, using our intuition and using our observation, it means we're gonna graph the function. Okay, and hopefully, by looking at the graph, we can see something. One more time, I gotta emphasize that your observation, our observation, may not be correct. But for now, we're gonna accept the method. By looking at the graph of the function, we can find the domain or the range of the function. Okay? We can kind of guess what the domain and the range is gonna look like. Example. I'll go back to our very first example, the easiest one. F of x equal to 2x minus 1. Alright? One more time, I'm saying that for now, we're going to determine the domain and the range using graphs, okay? But later on, when you move on to a higher course, we're going to do it algebraically. It's a more formal way, do calculation, do algebra to get the domain and the range, okay? Now let's start with the graph. X-axis, y-axis, this is the line, so I can graph it. The slope is 2, y-intercept is -1. So the graph is going to be like this. Okay, -1 right here. Okay, so as we just learned a minute ago, for the domain, we are thinking of x. For the range, we are thinking of y. For the domain, we're going to think of x. So the idea is this. We're going to trace along the graph. Okay, and we think of the x value means what? We think of left or right. And in this graph, we can go all the way from the very left to the very right without any restriction. So the domain is all real numbers. Domain is all real numbers, from -infinity to positive infinity. See? From very -infinity for x all the way to positive infinity for y. And similarly, you know that y is going to be the output, so y represents the range, right? So we're still tracing along the graph, but now we don't look left or right anymore. But we are looking up and down. So what? We can go down forever, we can go up forever. So the range still -infinity to positive infinity. Okay? How about another example? This one still alignment, special one. How about this? G of x is equal to, say, 3. Now, this is just a line with y equal to 3. Remember what we learned last time in chapter 2? This is a horizontal line, okay? Slope is 0. And if I graph this, I have this. This is my x-axis again. This is my y-axis again. This is a line. Y equal to 3 right here. And this is the origin, 0. for the domain and the range. For the domain, one more time, we are looking at the x values, right? We trace along the graph, and we see it's go to the left forever, go to the right forever, because the x-axis is the horizontal axis, left or right. So domain has no restriction from negative infinity to positive infinity. Now, here comes the main point I want to emphasize in this one. What about the range? You're still tracing along the graph, but you don't look left, right anymore. You look up, down. What's so special about this one? It doesn't go up. It doesn't go down. It stays flat all the time, right? So actually, we only have one value. See, the range go up and down, right? We look up and down. There's no point above 3, no point below 3. Only 3 for y value. So the range now is only one value. Okay. So the set of all the output y is just one value, y, 3. Okay. And that is the range. It's one value. How about one more example, or maybe two more examples before we move on? Try this. Say f of x, h of x equal to x squared minus 3. Okay? And let me try to graph this for you. X-axis right here, y-axis right here, and the graph, this one going to be a parabola, and the parabola going to look like this. Negative 3 is right here, and 0 is right here. Okay? That's the graph. So first, for the domain, we are tracing along the graph. Look left to right. See what? It's keep going up, but at the same time it's going to the left forever. It's going up, but at the same time it goes to the right forever. So the domain here is what? All real numbers from negative infinity to positive infinity. And what about the range? Now, the range, you're still tracing along the graph, but now you're looking up and down. It's going up forever, but it's not going down forever, right? The lowest point for y value is negative 3, including negative 3, and bigger. So really, the range is negative 3 or bigger, from negative 3 all the way to infinity. Okay? That's how you got the range. Okay, let's take a look at one more example. How about this? How about k of x? I'm using different letters to represent function now. Equal to square root of, say, x plus 1. Okay. And let me show you guys a graph of this. X-axis, y-axis. Okay. And the graph going to look like this. Like half a parabola, horizontal one. Okay? And this is an open dot at negative 1. 0 right. Okay, and now we're still looking at the graph to determine the domain and the range. Start with the domain. Tracing along the graph and look for left and right. The graph goes to the right forever, so go to positive infinity, and then go to the left forever. Oh, solid dot, I mean. This is solid dot. Okay. So, domain is what? All real numbers greater than or equal to negative 1. It's as small as negative 1 and then get bigger. You see what? The quantity inside the radical is going to be not negative, right? It's going to be greater than or equal to 0. So, this x is at less negative 1 and then bigger. The domain is negative 1 all the way to infinity. Well, you can look at the graph and see. And what about the range? Now for the range, we still trace along the graph, but we don't look left or right anymore. Instead, we're going to look up and down. See, the y value, can it go up forever? Yeah. Can it go down? Yes. Go down to where? Go down to 0. See, y value right here, 0. This point right here gives you the y value 0. The point right here is negative 1, 0. So the smallest value for y could be 0, and the greatest value for y is unlimited, so we'll go to infinity. So the range is from 0 to infinity, up and down. Okay. We cannot have any value for y below the x-axis, at least right here, 0, and then go up. This is a very common mistake when I put this question in the exam, actually, in a quiz or in the previous years as well. I asked for the range, and many people are going to answer, well, domain is okay, but the range is going to be from -1 to infinity as well. No, -1 you're going to see some point down here for the y value, but actually y value start from 0 and up. Okay? Okay, give you guys more example, one more, and then I'm going to move on. Now I'm going to give you a fraction. Okay, how about this? G of x